Okay, proving triangles are similar. We've talked before about proving triangles are congruent. Today we're talking about proving that they are similar. We talked last time I saw you on block day. We talked about what makes a triangle or polygon similar. They have to have corresponding angles that are what? Congruent. And corresponding side lengths are what? Not congruent, proportional. Okay, so we have shortcuts now. Remember when we did congruency, when we had side, angle, side, angle, angle, side? Do you guys remember that? Side, side, side? Okay, same concept, only now we're going to use it for similarity. So the three that we have are angle, angle similarity, side, angle, side similarity, and side, side, side similarity. It's important to put the little tildes at the end to show that this is similarity. Anytime you're dealing with angles, for similarity, the angles have to be congruent. So right here, if I can prove that two corresponding angles are congruent, I can stop and say the two polygons or the two triangles are similar. Here, now when it says side, angle, side, guys, please stop. Do these sides have to be congruent or proportional? Thinking about similarity. The sides are what? They're not congruent, they are proportional. Okay, same thing here with the side, side, side. The three corresponding side lengths are congruent or proportional? Proportional. All right, let's go ahead and start some examples. Are the triangles similar? If not right, not similar. Are the triangles similar? If not, right, not similar. Okay, number one. Triangle ABC such that AB is 9, AC is 6, and BC is 6. It looks like that. Okay, and now we have triangle EFG such that EG is 8, GF is 8, and EF is 12. And here's what we're going to write on this side. Number 1A, I'm going to give you triangle ABC is similar to triangle blank. You're going to fill the blank in. If they are similar, you're going to write the similarity statement. And in line B, you're going to write down what you used. Angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Okay, now these first two involve an angle or angles. Do I have any angles given at all in either triangle? No, so which one am I going to have to use? Side, side, side. Now I'm going to ask this question I've already asked a number of times. Corresponding side lengths are congruent or proportional? Proportional. So we're going to write our extended proportions. Now remember we've talked about matching small with small, medium with medium, and large with large? Same concept. Okay. I'm going to go with the small. What's the smallest side here?
AC 6.
6. There's two of them, right? The AC and the BC. So I'm going to put 6 equals 6 over. What side lengths would it correspond with over here? 8 over 8 and 8 equals 12 over 9 or 9 over 12? We have to go in the same order. And then we're going to reduce each fraction. Let's start with the 6/8. What divides into 6 that can also divide into 8? 2. What's 6 divided by 2? 6 divided by 2 is 3. And 8 divided by 2? 4. All right, the second 6/8, should that reduce to the same thing?
Yes.
And the last one, the 9/12, what goes into 9 that also goes into 12? 3. What's 9 divided by 3? And what's 12 divided by 3? Did they all come out to be the same? Yes. So are these two triangles similar? Yes, by angle, side, or side. And we want to make sure that we put side, similarity. Because if you don't, it looks like it's side, congruence, and we're not talking about congruence here. All right, now let's go in order. A, B, C runs along the larger side and then down the smaller side. We could do it this way or this way. It technically doesn't matter. I'm going to start with the E. So what would I do? E, F, G. Any questions? Yes.
Why is there not a little squiggly mark?
Why what?
After yeah.
Why do I put it there?
Yeah, what is it? What do you mean?
Okay, it means similarity.
Oh, okay.
And why do we put it? Because if I don't, have we seen side somewhere else before?
Yeah.
Yeah, on our congruency unit a few units back. So without it, it looks like I'm saying, oh, they're congruent by side. And I'm not saying that. I'm saying they're similar by side.
Thank you.
You are welcome. Thank you for asking. All right, number 2. How about yours? Somewhat. Okay. So, yes, that's always great. And a 3-day weekend for you guys, which is nice.
Me. I gotta be here tomorrow.
We have to be here. We have in-service. We have to prep and plan. Yeah. Right here, or you can do it right here. There's a thing right there. For the year, second semester.
Are we gonna have a final? Like the end of first semester?
Right before winter break.
Wait, what the heck?
All right, shh, gentlemen, ladies, we are paying attention.
Candy girl.
Christian. Okay, can you guys see that there's 2 triangles? There's a big triangle ABC and a smaller triangle DEC. Can you guys see that? Okay, I'm going to draw the bigger one. I'm going to redraw. Do you guys remember that unit we had with overlapping triangles?
Yeah.
Yes? That's kind of what we're dealing with here. Well, not kind of. We are dealing with overlapping
I don't remember this.
triangles.
B on the left and the same side.
Thank you very much. Hey, no, that is important. A, B, C. Okay, and then the smaller one, D, E, C. Now the 2 triangles overlap in a corner or a side.
Wait, what are 3 triangles? Wait.
This is the original drawing, and I split the 2 triangles apart. So this is my redraw.
Oh, okay, I got you.
So this is the original, and I split them apart. All right. Do the two triangles overlap in a corner or a side?
Corner.
Which corner do they overlap on? Do you see that they both share angle C? Angle C, the smaller triangle has, and angle C, the larger triangle has. Okay. What else? Did they give us anything else? Did they give us any other angles? No, gentlemen. They didn't give us any other angles. They didn't give us any side numbers either, did they? No, but they gave us this, which tells us what?
They're parallel.
They're parallel. So I want you guys remembering, I need you guys paying attention. I need you guys remembering back to last year for you guys in Math 1, and we've also talked about it this year. when two lines are parallel cut by a transversal, what do we call these two angles here? This is the bottom right, this is the bottom right. Corresponding, you had the C part right. Okay. Corresponding angles are congruent as long as the arms of your F are parallel. Do you guys remember that?
Yeah.
Okay. If you can make the F shape and the arms of your F are parallel, then these corners here will always be congruent. Do you guys remember this? Okay. That's what we're going to use here. Can you see the F shape here? Whatever you guys are doing needs to stop. Take your hood off. Okay. And are the arms of our F parallel? Which means that this corner is equal to that corner. Okay. So in my big triangle, what corner am I pointing to right now? Angle B. And in my smaller triangle, what angle am I pointing to? D. Now, I messed up on my markings. Why is that? It needs to be 2. I only put 1, and it should be 2. I'm going to put 1, 2, 1, 2, because I already have 1 down here. Okay. Look at your markings. Do we have enough to say the two triangles are similar? And if so, by which similarity statement? Angle, angle. Do we all agree? Two sets of corresponding angles are congruent, which means the two triangles are
Congruent.
not congruent.
Equal. Corresponding.
Similar.
Great.
Okay, 2A. Triangle ABC is similar to triangle blank 2B blank. Let's fill in 2B first because we just said it. The two triangles are similar by which statement? Angle, angle, similarity. Not congruent, similarity. Okay, let's see. A, B, C goes from... Did I label them incorrectly?
You did.
Okay. A, B, C corresponds... Okay, I went from no marking, double marking, single marking.
EDC.
EDC. Does that make sense?
Yeah.
Are we good?
Yeah.
Okay. Next one, number 3. A, B, C, D, E. Draw your pictures quickly. A, B, C, D, E.
Whoa.
I'm going to put up here 3A. Triangle ABC is similar to triangle blank. 3B blank by which congruency statement. And there's more information I haven't given you yet. I just want you to get your pictures down.
You have any plans for the weekend, Ms. Torres?
Trying to think. Oh, it's our church's Halloween party this weekend.
Hey, that's lit.
The trunk or treat.
Are you guys going to visit some elephants and go trick or treating?
All right. Okay, guys, numbers. Come on. 3, 4, 10, 6. The trunks of your car, not the trunk of an elephant. Okay, 3, 4,
That's science.
10, 6. All right. We've dealt with these bow tie type of problems in the past. What do we know, even though they're not marked, what do we know about those two angles?
Vertical angle.
Thank you. Vertical angles, and vertical angles are? Okay. I don't have any other angle markings. No lines are parallel, so I can't put any markings in. But I have these side markings. If anything, which one do you think I'm going to try to use? Can you see it looks like side, angle, side? Yes or no?
Yeah.
Side, angle, side. Can you guys see that?
Yeah.
Now, that doesn't mean they're similar. We have to check it. Side lengths have to be congruent or proportional.
Proportional.
Okay, so since we don't know if it's been rotated, let's go small to small, large to large. What is the smallest side here?
That's 3.
3. What's the smallest side here?
That's 6.
6 equals, what's the larger side?
4,
Over
10,
10. And let's reduce. 3 over 6 reduces to 1 over
3, 2.
1 over 2.
Wrong, Judy.
wait,
No, he was right.
Oh.
Well, 1 over 2. When you fixed it, you were right. 1 over 2 equals, what goes into 4 that also goes into 10?
2,
4 divided by 2?
2/5.
2 and 10 divided by 2. Do they come out to be equal?
No.
They do not. So can I say the two triangles are similar?
No.
No, they are not. Let's just pretend for a second they both came out to be 2/5. 2/5, 2/5. Would they be similar?
No.
Yes, by what? Side, angle, side, similarity. Okay, but here we're going to write not similar.
Not sin.
And I'm going to put a little X mark up there. Are they?
Bro,
Good.
these are hard.
Okay, number 4.
Look insane.
Are we good with number 3? Any questions on 1, 2, or 3? Okay, number 4. A 1.7 meter tall child
That's a big key. I hope this song's just all good, but
1.7 standing next
yeah.
to a flagpole. All right. The child's shadow is 1.3, can you guys turn that off please? 1.3 meters long. At the same time, the shadow of the flagpole is 7.4 meters long. And now for the question. How tall is the flagpole?
That's a lot to write.
Well, you should have been writing with me.
It's pretty tall. Are we gonna write all that?
Yes. You should have been writing with me. How many of you guys are writing with me? There you go.
That's a class one.
I think more than half. Most. Okay, we're going to draw our picture.
I don't want it. I'm tired.
Here's our flagpole.
That's a big flagpole.
I'm just gonna do it.
All right, so here's the shadow of the flagpole. And how long is the shadow
Pretty
of
long.
the flagpole?
1.3 meters long.
That's the child's shadow.
Oh, 7.4.
7.4 meters.
Come on, Judy. That's what you
Okay,
do.
how tall is the flagpole? Do we know, or is that what we're looking for?
I'm looking for it.
Okay, well, hold on. So, here's your child. No. Well, if I put him right on it, he's going to look like he has the pole coming out of his head, so that's the best I can do.
I keep on shooting.
Give him some hair.
It's okay.
Where's
All right.
the food?
Guys. So, now, do we know the child's height? How tall is the child?
1.7 meters.
And how long is his shadow?
1.3.
Okay. When you have people or items, whatever, standing next to a tree or a flagpole and you're dealing with shadows, these two triangles will always be similar triangles. You have this angle in here that they share, and you have these corresponding angles up here that are congruent, so they are similar. You don't have to prove it, just know that they are. So we're going to make a proportion to solve. We're going to do flag over child equals flag over child. What's the height of the flagpole? What's the height of the child?
1.7.
Equals, what's the shadow up for the flagpole?
7.4.
Over, what's the shadow for the child?
1.4.
And that there is your equation, your proportion. X over 1.7, height of the flagpole over height of the child. Shadow of the flagpole, 7.4, over shadow of the child, 1.3. Let's cross multiply. 1.3 times x is 1.3x. Does anybody have a calculator out that can multiply this for us, since not all, we don't all have it? What is it?
12.58.
Thank you, 12.58. And then we divide both sides by 1.3. Those of you with the calculators, will you please plug it in for us? 2 decimal places if it comes out to more. 9.68 meters. Questions? Okay, we do have another one.
We have another one.
Another word problem. Number 5.
Can I go to Russia?
Hustle, please. Sophia wants to find the height of a tree for a science project. Write with me, please. Hello, Mrs. Torres. Yes. We're doing notes right now. Okay. All right, write with me. Sophia wants to find the height of a tree for a science project. Period. What? Sophia is 2 meters tall. She stands 8 meters away from the tree. And her shadow is 3 meters long. And now for the question. How tall is the tree? We have enough. Okay, so let's draw our tree. Okay. Do we know the height of the tree, or is that what we're looking for? Okay, so I'm going to call this here X. Do we know the shadow, the length of the shadow for the tree? She stands 8 meters away from the tree, and her shadow is 3 meters long. Okay, we do not. Do we know her height and her shadow?
Yeah.
Is she standing next to the tree?
No, she's standing 8 meters away.
Okay, so 8 meters away. She is standing. And her height is what?
2 meters.
2 meters. And what's the length of her shadow?
3 meters.
3 meters. Now when she's standing here, the tip of her shadow meets up with the tip of the shadow from the tree. Okay, now you have to be careful, very careful on these. A lot of kids will do it like this. They'll say x over 2 equals 8 over 3, which is incorrect. X over 2, is that part correct?
Yes.
Now, she's standing 8 meters away. Her shadow's 3 meters, and the tip of her shadow meets up with the tip of the shadow of the tree. So what is the length of the shadow for the whole tree? 11. Do you guys see where the 11 is coming from? Yes?
Yes.
Yes.
They never said the shadows meet at the end.
I know. It should have, and that's why I'm saying it now. And at the same time of day as well. All right. So what do we say then? X over 2 equals what? X, tree over child, please stop, equals tree over child. X over 2 equals 8 or 11? 11 over the shadow of the child or the young girl. And then cross multiply. What's 3 times x? Equals 22. And divide both sides by 3. 22 divided by 3 to 2 decimal places is 7 point what? 33 meters. All right. You guys do have one like this in homework, and the wording's the same, so you assume that it's the same time of day and their shadows meet up at the end. Got it?
Yeah.
Questions? All right, that is it for this lesson.